practice this loads and loads of times, and I have to make sure that I don't get over enthusiastic and start talking about a whole range of other things, because normally I will talk about silk and the material science and the biology behind silk. But I thought today, for a bit of inspiration, we're going to be looking a little bit more towards the past to find out about where our inspiration from silk comes from. And so this is my first sort of historical lecture. So hopefully we'll find out a little bit about these things. So this is Bombyx mori. This is the Chinese mulberry silk moth. They make about 1 trillion of these every single year to make about 400,000 tons of raw silk, which gets turned into about 140,000 tons of textile silk. But how does this play into the field of medicine? I mean, we've been looking to nature for years and years and years, and whenever we look to nature, nature has these wonderful solutions that can improve the quality of our lives. And so, where does it start from? Well, we're going back 4,500 years now to Shengnong, who was known as the divine farmer, one of 3 divine entities that would taught the Chinese agriculture, basically, and a whole range of different herbalists and the use of medicine taken from nature. Shengnong started doing this, and through a series of collections of oral traditions. Because if you think about this is 4,500 years ago, so they didn't have printing presses here, they didn't have the internet. How do you actually go about transferring information? Well, it was word of mouth. This got condensed into what we know throughout history of these things called materia medica, basically medical textbooks. We're going to be looking at a series of medical textbooks over the next few minutes. This one, the first, which is the Divine Farmer's Classic of Materia Medica, combines about 600 or so different plants and a few animals to look at how they can heal ailments. Surprisingly so, given the fact that this comes from China, which is where the mulberry silkworm was domesticated, it's where we get all of our silk effectively from. Silk doesn't feature in this textbook, the original sort of Chinese medicine textbook. The only time you see a silkworm featuring is a little bit in a poorer state than the one you saw in the last slide. It's here, where the silkworm larvae are deliberately infected with a fungus, and that fungus is then boiled and used to treat a whole range of different ailments. There's another type of silkworm, the Japanese oak silk moth, which is also infected with a cordyceps type fungus. The last of us, it's exactly that kind of fungus that is boiled down, made tea. It helps with a range of different ailments. You can still find this in Asia, everything from sort of headaches through to mumps. But in terms of using silk as a material, we didn't really see much of it at all in sort of the history of Asia. So we then start to look towards the west for other sources of silk. Well, one source of silk is a spider, for example. And going back only a couple of thousand years now to Pedianus Dioscorides, who did one of the very first Materia Medica. This is him talking to, I'm going to be completely honest, I don't know quite how to pronounce all of these names, so if I get them wrong, please let me know. This is Heraeus, or Heraeus, who is the source of inspiration. She was responsible for telling Dioscorides about the medicinal use of plants. Here is a picture of her presenting Dioscorides with a mandrake root, which was known to be screaming and cause death if you pull it from the ground. This is Harry Potter stuff, but obviously back then. So much so that a dog actually picked it out of the ground, and this is the picture of the poor dead dog as it pulled the mandrake root out of the ground. But it goes to speak to the use of nature producing these fantastic sources of medicinal uses. So Dioscorides did effectively the Greek Materia Medica here, and when we look to the uses of silk within this, it was found. Spiders' webs were found. They were often originally bundled up into a tiny little bag, boiled with roses, and then popped under the armpit, and that was great for sorting out bouts of Corterian fever. It can also be used for small cuts And actually, that use of silk as cuts and as a striptic to prevent bleeding, we'll start to see being used more and more and more, because as time goes on, we started to get this movement. Do anyone know what these lines might represent at all? These are the Silk Roads. So some of them go over water, which confused me when I first found out, but they're basically trade routes. Trade routes. Silk was such an economically and historically important item. It built transport networks across the globe. Venice is actually based on the trade of silk. It generated so much money for that economy. But we have these trade routes, and these trade routes are moving materials backwards and forwards, and silk was one of them. And silk eventually ended up from China over into Europe in the hands of the Roman Empire. We have Pliny the Elder here. They weren't 100% sure about where silk came from. In his description of Ceres, the people who make silk, the first description of the Chinese in general, the first race they encountered the Ceres, so famous for their fleecy product of their forests. The Ceres are famous for the woolen substance obtained from their forests. After soaking in water, they comb the white down off the leaves. So having absolutely no idea where silk really came from, but silkworms spinning their cocoons on their host plant, which is the mulberry tree, and you do get silk on the leaves of the tree. So you can start to see how, by word of mouth, this could get misinterpreted. But so manifold is the labour employed, and so distant is the region of the globe drawn upon to enable Roman maiden to flaunt transparent clothing in public. And this talks more about the quality of the material. This material was incredibly fine, incredibly strong, so you didn't need much of it. So much so that this was originally used as money. It was patches of silk were given to guards on the borders of China to specifically trade. It was so valuable actually, there were emperors that banned the trade of silk because the entire Roman economy was hemorrhaging money into China because of their exports. So they were literally just buying so much silk up. But if you could find silk, and it was only in the very, very wealthy sort of towns and cities, there were other uses than just clothing. And an example of this is Galen of Pergamum. This is the person who wrote the Materia Medica for basically Galenic medicine, which is all of Western medicine is based on this person's approach to stuff. So this is Galen here, and he was the first to demonstrate the use of ligatures. So actually doing surgery. This is high-end sports medicine. This is a gladiator that had ruptured ligaments. And the advice was to take the finest, strongest material, often found in areas where the ladies wore the finest clothing, i.e. silk materials, and use that to sew up broken tendons and ligaments. So this is one of the first examples of using silk as a true biomaterial. It's not just as a medicine, but actually as a biomaterial. We then sort of find that for another sort of 1500 years or so, not really much happens. I think there was a general mistrust of spiders and silkworms. I mean, the Romans and the Greeks have the story of Arachne, for example, and a range of sort of negative elements surrounding spiders, which kind of makes sense. You know, you want to keep away from things that might make you poorly if it bites you, for example. So silk wasn't really used that much. It was occasionally used to treat shaving wounds, basically, to staunch the flow of blood. This was so much so that it's still maintained up until the 100 Years' War. This is the Battle of Crécy, where French soldiers were given small packets of spider silk. They were often sort of dipped in a little bit of oil and a little bit of vinegar as well, and they'd be applied to wounds to stop the bleeding. This sort of carried on into the late sort of 1500s or so, where even in, now I would be amazed, you could cheat and find out, does anyone have any idea what these are? Okay, this is an obscure, these are the four fairies from Midsummer Night's Dream that visit Titiana and Bottom in their dream, and one of them is called Master Cobweb. And this directly comes from A Midsummer Night's Dream. I shall desire of you more acquaintance, good Master Cobweb. If I cut my finger, I shall make bold of you. So this is direct evidence from Shakespeare that they were using webs to stop the staunch of flow of blood. This moved on to the French Civil War. This is fantastic. I mean, we just have to sort of spend a moment thinking about this. This is 500 years ago, and effectively, Ambroise Paré, a Civil War surgeon, rediscovered Galenic medicine, rediscovered the fact that, wait a second, you can use silk to tie things up. Well, I'll tell you what, on the battlefield, rather than just dipping the limb that isn't there into boiling hot oil and cooking at the end of the route to stop the blood flowing, why don't we just tie up the tubes? And that's exactly what he did. He pioneered vasculature, ligature, and vascular medicine. 500 years ago, this person was tying up veins and arteries to stop chronic hemorrhaging on the battlefield. So, and silk was used specifically for that. So absolutely incredible to think that this was being used. I find that remarkable. There was some, and I can only find one unusual example of medicinal drops or silk being used as a pharmaceutical, medical intervention. This is known as English drops. Now, there was a person called John Stoddard in the sort of 1670s or so who came up with a remarkable recipe to treat a whole range of sort of lethargy, which is taking a couple of pounds of ivory, 5 pounds of the skull from hanged criminals, and a whole range of other sort of relatively gruesome things, boiling them up, filtering them and straining them, and then you take a couple of drops and that'll perk you up. Well, I'm pretty sure it would do. And silkworm, silkworm cocoons do a sort of feature in that, and actually realistic. And they describe taking, transforming an acid into a fort of snow. This is basically protein precipitation under acidic environments, and I think what they're doing is that they're just turning it into a really strong ammonia by taking the protein, boiling it down, and turning it into ammonia. But so powerful was this, and King Charles II was actually really, really into science and supporting science. He actually awarded the innovator of this, John Goddard, the first ever British Nobel patent based on an innovation surrounding the application of silk in medicine, which I thought was quite fun, actually. Monsieur Le Bon, who we'll see at the very end of this talk, was a French mayor in the 1700s. He used spider silk, and he said it was far better at perking you up effectively compared to the English crops, and it did not have the fetid smell, which is, my goodness, I mean, crikey. But anyway, the other story I want to tell also sort of extends over to France. This is an example of silkworm cocoons. If you were running a silk field, a silk mill, and you were given a whole bunch of these cocoons, you'd be very, very happy. However, if you were a farmer and all of your silk cocoons started looking like this, like they did in 1600s or so, 1670s I think, this is a real problem. This was a plague. This was a disease called the pebrine, which basically decimated the southern French sericulture industry. A real significant problem. So much of a problem that the head of the industry at the time, a chap called Dumas, asked Louis Pasteur to look into this. So Louis Pasteur looked into this in 1865, and he spent 5 years of his life specifically researching this disease, to the point where he'd done so much work and actually identified that it was 2 individual microbial agents that were responsible for this disease, and actually led him to the foundations and the understanding that microbes cause disease. So Pasteur's innovations and his contributions are based on the research that he did into this, and he actually managed to save the French silk industry by saying anything that's infected, just get rid of it straight away, scorch the earth, burn it, get rid of it, and actually managed to save it. And it was about this time, and Pasteur's ideas about the microbial transmission of disease, we have this person, Joseph Lister, was reading these papers, was looking at these reports, and this led him to understand the concept of antiseptic materials. And he actually produced one of the very first British medical materials, which was this green oiled silk, English oiled silk, a non-adhesive waterproof surgical dressings. This is one of our very first proper biomaterials based on silk. Silk mixed with a little bit of dextran, starch, and carbolic acid. Again, think back to the French creosote. They were putting their spider silk in a bit of oil and vinegar. It's that acidic environment, it's that slightly hydrophobic nature to it. That was responsible for stopping the wounds getting infected. And so Joseph Lister actually produced this with Moore and Sons, if I remember rightly. You could buy it. So really fascinating that all of this sort of circles around silk as this sort of marvelous material to get you started. So I've gone over sort of a few thousand years up until the point where we first started getting things like this sterile silk suture. But what sort of since then? Well, I didn't want to spend too much time going on this, partly because, look at this, 15 minutes and 50 seconds. I've got about 4 minutes, so I'm not going to keep on jabbering on. But what's happened in the past sort of 100 years or so? Well, there's been a huge amount of innovation within the silk industry, and that's partly because of a realization. The realization is that you don't have to use silk in fibrous form. What you can actually do is chemically unspin it back into a liquid. Because when we look at the animal themselves, actually the animal is a big sac with liquid silk inside it, and just through the act of pulling it through this tapering duct, it transforms into a solid fibre. So if you can get the liquid silk, you can suddenly start reprocessing, and you can reprocess it into a range of different types of forms. So you take the liquid, you can turn it into a sponge, you can turn it into a film, you can turn it into a gel, and at a rate of around about 1,500 papers being produced every single year, that's 3 a day within the community, specifically focused on the biomedical, biomaterial applications of silk. There isn't actually a single part of the human body that hasn't been recreated in silk. And there's a range of different companies exploiting this and trying to understand it a little bit better. This is just a snapshot from about 5 years ago, but they continue to increase. So there are companies that are making artificial silk knees. There are ones that are making a whole range of coatings for implants. There are ones that are making nerve guides. This is cool. You get a broken nerve inside your body if you're partially paralyzed. They make a tube of silk, poke little silk fibers down it, and the neurons can send out little axon threads. I can't remember. Basically, they can rewire themselves. They can grow like a highway down this silken tube in order to restore function. It actually works. They've topped out the limit in rats, and they're now to some larger animals to prove that it's really working. Of course, there are a whole range of other applications of silk, because silk will always be associated with sort of luxury and fashion. These are artificial spider silk brands, everything from a silken tie through to concepts of both very confusing 2 companies, both called Spider, one in Japan and one in Sweden, but making textiles out of silk. But I would say, in general, we're not quite there yet with the recombinant approaches, and practically we're probably going to end up be doing something more with the Bombyx Mori when it comes to the biomedical side of things. So I'm going to leave you with this. This is from Monsieur Le Bon. I said we would be coming back to this person at the end. So many examples ought to show us of what importance it is to neglect something in the study of nature. What first seems of no use or almost impossible to be put into execution oftentimes turns the greatest advantage and becomes easy by care and industry. What an inspiring paragraph when you think, let's look to nature, learn how it does stuff, and try and replicate it. And so with that, I'd like to thank everybody, and that's it from me.